In this clip, I'll tell you the story of the Ariane 5 rocket. You can find a longer wrap-up of the story at the link you see on the screen. In the mid-90s, the European Space Agency was trying to build a heavy-lift launcher module to comfortably carry satellites into space. The maiden flight of the newest Ariane 5 rocket was planned on June 4, 1996. It was an unmanned flight. The result was that the rocket self-destroyed nearly 40 seconds after takeoff, burning into flames some $7 billion value. The explosion was the effect of an abrupt course correction that occurred to compensate for a programmatically detected wrong turn that in effect never took place. How was that possible? Well, according to the official report of the inquiry board, the primary technical cause of the failure was an operand error in a numeric conversion and the lack of protection of this attempted conversion. In software terms, it was a bug in the software, an unhandled exception. The bug and the crash happened to be a single thing, and in a way, together, they provided a single, unified, but devastating experience. The module involved with the failure was the inertial guidance system. The inertial guidance system was a device designed to track the orbital velocity of the rocket. The operand error that triggered the crash occurred in a component of the module, probably a class, that was of no use after takeoff. In other words, there was a piece of software added just to make it faster to reposition the rocket after an interrupted countdown. Call it a utility, call it convenience code. Fact is, that code had no role in the actual functioning of the rocket. Because of this, it got not much care from developers that simply assumed this will never fail, given the context. This class, developers probably thought, is supposed to stuff incoming values to a 16-bit integer variable, and wrong assumption, whatever value we get will always fit there. But nobody had a chance to test it really in the air. Let's see the effects of such a wrong assumption about the context of a given piece of software. In this particular case, the Ariane 5 experience, steering was controlled by the onboard computer, and 35 seconds after takeoff, everything was absolutely okay. Then the operand error unhandled occurred, and it bubbled up until it reached the onboard computer. Based on the numbers received from the inertial guidance system, the computer decides that the rocket needs a course change. The onboard computer then orders a course correction, an abrupt course correction. However, unfortunately, given the physics of the rocket, such an abrupt correction was the same as self-destruction, and then the rocket crashed. Is there any moral in this? Is it all about having tests and exception handling? Testing and exception handling is, of course, critical to have, but I wouldn't say that beyond facts it was the main reason of the Ariane 5 crash. And what was the problem then? Pressure put by stakeholders on operators, including developers. And to face pressure and meet probably shockingly tight deadlines, working solutions were just adopted. So a 16-bit variable was reckoned enough because it worked in the air for the Ariane 4 rocket. except that the new Ariane 5 rocket was much faster and then capable to generate larger numbers that couldn't fit into a 16-bit variable. This anti-pattern is also known as architecture by example. But then again, architecture by example is for the most part the result of pressure. Frank Lanza, at the time of the Ariane 5 disaster, executive VP of Lockheed Martin, a US aerospace company, said, "There is no life today without software." And this was true at the time of the Ariane 5 disaster, and even truer today. Any lessons? Which are then the best attributes of software? Software must be focused, which means strictly oriented to the actual tasks and facts. It has to be maintainable, which means easy to evolve and rewrite from scratch if necessary, and also reliable, which means that all possible worst cases scenarios are duly considered. In summary, the software doesn't have to be a big ball of mud, and I'll talk more about big balls of mud in the next clip.